Welcome to the next lesson in this chapter, where we are going to write unit tests for the Evently application. I won't be spending too much time on this introduction, so let's jump straight into the code. We are going to write unit tests for the domain layer of the events module, and we are going to start by introducing an additional test project under the test folder inside of the events module. So let me choose an XUnit test project, and I will call this project Evently modules and then the name of the module, which is events, and let's call it unit tests. Let's choose .NET 8 and let's create this project. I'm going to give our unit test project a reference to the events module domain layer, which is this project here. So let's add this reference. And then I'm going to update the project file slightly. We won't be needing this part, and we should update the existing NuGet packages and also introduce a few additional ones. So let me manage the NuGet packages for the unit test project. And I want to install Bogus, which is going to help us in generating some fake data. And I also want to install Fluent Assertions, which I'm going to use to write my test assertions. So we're going to install the latest versions of both of these NuGet packages, and then let's go ahead and update the existing packages that we have inside of our unit test project to the latest versions. And now let's go ahead and start writing our unit tests. I'm going to start by repurposing this default class into a base test class. I'm also going to create a respective folder. Let's call it abstractions. And let me move my base test class into this folder. I'm going to create a protected read-only field called Faker, and this is an instance from the Bogus library, and let's just create a new instance. We can also make this a static read-only field because I don't expect to be changing it, and we are going to use this to generate some fake data when running our tests. Then I'm going to create a helper method. It's going to be a generic method, and I will call it assert domain event was published. Let's give it the generic argument and then an entity instance as the argument for our method. Let's also introduce a generic constraint that our generic argument has to be an iDomain event implementation. And then I can say entity domain events, and I want to look for events of a particular type, which is my generic argument. And then let's say single or default, because I'm only expecting to get a single domain event of a particular type. In the unfortunate case that our domain event is null, let's go ahead and throw a new exception. And I will say type of t, and then let's say name was not published. And if the domain event is not null, let's go ahead and return it from this method because we will be using from our test cases. Then let's go ahead and create another folder inside of our unit test project, and let's call this the events folder. And inside of it, I'm going to create one test class, which is going to be my event tests. Let's make this class public. It's going to implement our base test class. And now it's time to write our first test case. And what we are going to be testing is the respective event entity from the domain layer of the events module. If we take a look at this entity, you can see that we have quite a few things to test. We can start from the static factory method, which returns a failure if some conditions aren't met. It also raises a domain event, and then we have a bunch of other methods like publishing an event, rescheduling an event, canceling an event that we could also test as part of our unit test project. So let's start with the create method, and then we're going to continue with the other examples. For example, I want to check that the end date that I specified here precedes the start date. So let's create a test case for that. I'm going to start with a fact attribute, and then I'm going to say public void, and let's call this test create should return failure when the end date precedes the start date. I like writing my tests in the arrange, act, and assert format, and let's fill in the individual sections. Before we add what we need in the arrange section, let's take a look at what the create method is expecting. It needs a category instance, and then the title, description, and location for an event, as well as a start and an end time. So let's begin by creating a category instance that we can use to pass it to the event create method. And we create one by specifying a category name. I'm going to use my faker to generate a random genre as the name of our category. And then let's create the start and end times for our event. So let's say starts at UTC, and it can start at the current time. And then I need another datetime instance for the ends at UTC value. and I can say it's going to be the start set value, and we can add 1 negative minute to make sure that the end date is in the past. Now I can pass in the category instance. For the title, let's use Faker to generate another random genre. I'm also going to do the same for the description, and for the location, let's say Faker address, and then let's generate a street address. Now let's pass in the starts at and ends at time, and now we can take the result of the event create method. Now that I have my result instance, I want to check that the error that we get back should be, and this is the Fluent assertion syntax, and now I can say event errors, and I can check that we got back the concrete error that I was expecting. In this case, the error value should be event errors, and date precedes start date. So with our first unit test in place, let's go ahead and execute it from the Test Explorer. Here is the one unit test that we have. I won't be running any of the other tests together with our unit test so that it completes faster, and you can see that our unit test has finished and it's successfully passing. Another thing that we could test with our unit test is that we have raised a particular domain event. Now, if you go back to the event entity for a moment, this would be the event created domain event. And let me show you how we would write a unit test for this. So we can say create should raise domain event, and we can say that the condition is when event is created. To make the test succeed this time, I'm going to get rid of the end date, and we can pass in a null value. I'm also going to create a variable to hold my event instance, and it's going to come from the result value. And then we can get any domain events that were raised by calling the assert domain event was published method, which is available on our base test class. The event that we are looking for is event created domain event, and then I can pass in the event instance, and we expect to get back a domain event instance. Finally, let's assert that this is the domain event that we are expecting. So I can say domain event ID should be, and I can pass in the event ID instance as the value that I'm expecting. Let's go ahead and run the two unit tests that we have. And in this case, we are checking that the event create method also raises the respective domain event on our domain entity. And now, in order to save us some time, I'm going to introduce a bunch of additional test cases. You can grab all of these test cases from right under this video, and then let me walk you through the unit test that we have here. The next test case I have is checking the publish method, and I want to make sure that it returns a failure result when the event is not in a draft state. And the arrange step for this test involves creating a new event instance, and then we're going to publish this event instance as part of the arrange step. In the act step, I'm going to call the publish method again, and then we can check that the result that we get back contains the error that the event is not in a draft state. The next unit test that I have is also testing the publish method, and this time I'm making sure that when we publish an event, we should raise a respective domain event. In this case, the event publish domain event. In the next test, we are checking the reschedule method, making sure that if we reschedule an event, we also raise a respective domain event that's going to notify the other components inside of our system. And then the next few test cases I have are for the cancel method when we want to cancel an event. This first test case is checking that when I cancel an event, we are raising the event cancel domain event. Now, if you take a look at the arguments of the cancel method, you can notice that I'm passing in the current time. Let's take a look at what the cancel method implementation looks like. And here you can see that we are using the current time to check if the event has not already started. If that is the case, we can return a respective error. And this is a very simple way for how you can test your domain logic that's based on the current time. You just pass in the current time value as an argument into your method instead of hard coding date time UTC now inside of your actual implementation. So this implementation, although it works at runtime, is not testable, whereas this implementation, where you just pass in the current time as an argument, is very testable. That's because inside of your tests, you can provide the value for the current time that you need to cause the required state in your system so that you get the expected behavior. In this case, we want to make sure that we can cancel this event. So we are testing that the respective domain event was raised. I also have another test that's going to first cancel an event and then attempt to cancel it again. And this time we should get an error that the event was already canceled. And then I have another test where I'm actually passing in a datetime instance that is in the future. And this test is going to fail against this condition here because the start time of the event is going to be less than the current time that we specified as the event argument. So let's go ahead and run the unit tests that I introduced for the events entity, and you can see that all of our unit tests are passing and they are also executing very fast. We can run 8 unit tests in just about 30 milliseconds. Now I'm going to introduce 2 more test classes into my unit test project. The first one is going to be the category tests class, which is doing some simple unit testing on the category entity. And you can see that we are doing simple things like asserting that a domain event was published, another test checking if a domain event was published, and another test checking if a domain event was published. So we are just verifying that calling the respective method on the category entity is producing the desired behavior. In the ticket types tests, we have a few similar types of tests. In this case, you can see that the ticket create method requires an event instance, so I have to create one before I can actually test my ticket type. We also have another test case trying to update the ticket type price, and this should produce a ticket type price change domain event inside of our domain layer. Let's go ahead and run all of the unit tests that we have for the events unit test project. In total, there are 13 of them, and you can see that all of these tests are passing. So a common theme between all of our unit tests inside of this project is that they are very simple. In the arrange step, we are just calling some methods available on the domain entities, and these will mostly be static methods. And then inside of the act step, we're also going to invoke some method that's going to trigger the respective behavior. And then in the assert step, we can just check that we either succeeded and got back the desired value, or that we got some sort of failure. We can also check that we are raising the respective domain events inside of our domain layer. And for the event tests, you can see how we check that we get back an expected error result. In case of our unit test, you can see how we are benefiting from using the result pattern. Because all of our methods return a result object, we can easily check that the state of the result is either successful, or if it's a failure, we can check the error instance and make sure that we get back the concrete error value. What's so good about this is if I go into my implementation and I change something about the value that's returned, for example, let's say I make a simple mistake like returning already canceled twice, and this is something that could be an easy typo. If you implement your tests correctly and then you rerun your test for the event entity, you can see that we are going to get a failing test, which also contains a very descriptive error message, which you can see here, and it says that the cancel result error property is expected to contain an error with the code of event already started, but what we got was already canceled. So this is how the result pattern can help us when it comes to our unit tests, because we can explicitly specify what is the error condition for a failure result instance. Another thing I wanted to comment on was unit testing your application use cases. Let me head over to the cancel event command handler, and I'm looking for the one in the events module, which is this one here. You can see that this class is also something that we could be unit testing. We just need to instantiate a cancel event command handler instance, provide mock implementations most likely for all of these dependencies, and we could use a library like nsubstitute or mock to provide these mocked instances and then configure any behavior that we need. An example of this would be making sure that we get back a null event, which would cause us to get back a not found error in this example. Then we can also try calling the handle method twice and seeing if we can get back a respective failure from the event cancel method. And of course, we can test the happy path of our use case. Now, most of the time, you can also write integration tests for your use cases, which is what I will be doing, and test the same exact behavior. The only difference is going to be that the integration tests are going to be much more valuable than writing unit tests for the same use case. This is because an integration test is going to use the underlying database and any other external dependencies that you can provide, and it will be much closer in behavior to the runtime execution of your use case in production. So this is why I'm going to write integration tests for my application use cases instead of unit tests, and I'm going to use unit tests only to validate the behavior of my domain entities. With that being said, let's go ahead and rerun the unit tests that we have for the events module, and you can see that all of our unit tests are passing, so we can slowly wrap up this lesson. In the next lesson, we are going to discuss integration testing inside of a modular monolith, and I'm going to show you my preferred approach to writing integration tests with the help of Docker containers for running our external services.